Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, we will first discuss about two different types of method, and in the last lecture we have seen different ways to solve the differential equation, and two different types of methods were the single step method and multi-step method. So we will see now another two different types of methods also, which is known as implicit and explicit method. Okay, that is, two methods are there. One is known as the explicit method. Explicit. Okay, so we are given a differential equation dy by dx is equal to some function of x comma y with y equal to y naught for x is equal to x naught. An initial value has been given. According to that, we have to trace the function, right? We are going to trace the function. That's what we have already explained now. Now we are going to trace the function by using. Now we are starting with x naught and y naught. Okay, x naught and y naught. And I told you that in single step we will find x1 and y1 by using x naught and y naught, and in multi-step we will use all other previous information also. So we are starting with x naught and y naught. Now in explicit method we will calculate our new value of yn plus 1. For example, if y naught is given, we will calculate y1. So in general, if yn is known, we will calculate yn plus 1 by using xn comma xn plus 1, similarly your old value. And this is a single step method anyway, because we are using only the immediate previous value, and this is known as the explicit form. That means we will be calculating yn plus 1 has some function of xn plus 1 yn. What is this some function? Some function means we will do some operation on xn plus 1 yn etc., and we will obtain yn plus 1. So this is known as the explicit method. And something known as implicit method is also the implicit. Okay, implicit method is also there. Implicit method. Here we will be calculating yn plus 1 by using our xn plus 1 and also yn plus 1. How this is possible? Yn plus 1 is calculated by using yn plus 1. It is possible only if you are writing an equation which contains yn plus 1 on both sides. That means you are writing an equation yn plus 1 as a function of xn plus 1 and yn plus 1. Okay, then after that you will solve this function for obtaining yn plus 1. Okay, so this is known as implicit method. Okay, I hope that this is very clear. So in the explicit method we will be calculating yn plus 1 explicitly. That means yn plus 1 is calculated by using xn, new values of xn plus 1, that is xn plus 1, new values of xn, that means xn plus 1 and yn. Okay, but here you will be writing an equation yn plus 1 as some function of xn, also xn plus 1 and yn plus 1. After that you will be solving for yn plus 1 and obtain yn plus 1. Okay, So this is known as implicit method. So previously we have seen different ways to solve the differential equation, and we can basically classify the methods into two, that is the single step method and multi-step method, right? Multi-step method. Okay, so single step and multi-step. What do you mean by single step? To calculate the new values of xn plus 1, that means x-axis and y-axis, yn plus 1, you will use to calculate, that is to calculate xn plus 1 and yn plus 1, you will use xn and yn, okay, or yn, okay, we can say xn or yn, or xn and yn, maybe both. So this is how, by using xn and yn, we will calculate xn plus 1 and yn plus 1, okay. This is the idea. But however, in multi-step method, to calculate xn plus 1 and yn plus 1 or yn plus 1, we will use not only xn and yn, we will also use the previous values like xn minus 1, maybe yn minus 1, maybe xn minus 2, yn minus 2, etc. Okay, we will use like this. So many values we will be using. So this will be used to calculate xn plus 1 and yn plus 1. So this is known as the single step and multi-step method. Now for calculating, and another one you have seen, that is the explicit and implicit method, right? Explicit and implicit method. So in explicit method, you will be using an explicit formula. What is this explicit formula? That is yn plus 1, that is the new value of the unknown function, is calculated by using, so we can say that we calculate the unknown function by using, you may use xn, you may use yn, you will use xn plus 1, so etc. Okay, you will use all these things to calculate yn plus 1. However, in implicit method, you will calculate yn plus 1. Actually you will use xn plus 1, you will also use xn, you will also write it as a function of yn plus 1. After that, you can see here there is yn plus 1 here and yn plus 1 here, right? Now you have to solve this equation. You have to solve maybe some equation, you will be writing it as an equation. So you have to solve this equation to obtain yn plus 1. So this was the method. So these are all the different methods, types of methods. Now we will see a technique or a particular method to solve the differential equation. So first method that we are going to discuss is the Taylor series. So all of you might have heard about Taylor series. Okay, Taylor's series. So the first method that we are going to discuss is the Taylor's series method. Okay. Now all of you know that we have a differential equation. For example, we have a differential equation. Okay, differential equation which is first order, maybe of the form dy by dx as some function of x and y, right? Maybe some example I can say, example dy by dx is equal to x square plus y. Another example, dy by dx is equal to x plus 2y. These are all the function of x and y. You can see on the right side, this is the function of x and y, right? X comma y, and this is also the function of x comma y. So that's why we are using the general form. Dy by dx is a function of x and y. Now you know that we want to solve dy by dx is equal to the function of x comma y. That means you want to find this function, you want to obtain the numerical solution, that is for y. That is, you want to obtain y. What is the value of this y? So y is the function. You can say that there was some function which is a function of x, and this is y of x. You want to find this y. Maybe the function, maybe suppose it is like this. You want to find this function. Okay, so that is nothing but the solution. But you are not going to solve it analytically. You are going to get the numerical values. Maybe you will be starting from some values. Maybe you have some values y naught, and you have some values like x naught. Then how to obtain x naught, and it will be given. For example, x naught is given and it is also given y naught. From x naught you will be proceeding further to obtain the x1, and for this particular x1 you will find what is y1. Now after, by using x1 you will find x2. Then for this x2, what is the value of y2? That is what you are going to find. And you are given, it has been given a differential equation of the form dy by dx is equal to f of xy. So these are all you can say the Taylor series method. Actually, it is a method which is a single step method. That means by using nth value of xn and yn, we will find xn plus 1 and yn plus 1. Okay, so as I told in the previous slide, you can see it will be given, this is given, x naught will be given and y naught will be given. Now you have to find the x1. So x1 will be chosen as a very nearest value, the nearest value which is having a gap of h. So you can write x1 is equal to x naught plus some h. And what is this value? x2. You can say that x2 is equal to, you have x1 here, that x1 plus h. Or what is x1? x1 is nothing but x naught plus h, then plus h. So x2 can be written as x naught plus 2h. So you can see here what we are going to do. We will find x or xn by using x naught. For example, you will find x1 which is equal to x naught plus h, and x2 is x1 plus h. That is nothing but, what is x1? x1 is x naught plus h, then plus this h. Okay, that is nothing but x naught plus 2h. Similarly, you can write x3 is equal to x naught plus 3h, and so on. In general, you can write xn is equal to x naught plus some n into h, and xn plus 1 is equal to x naught plus nn plus 1 into h, or you can write it is nothing but xn plus h. Okay, so this is how you are going to proceed. Now for each value of x you will be finding y. That means you have x and you have y, because you are going to find this function. You are going to calculate this function y. It is given x naught and what is y naught, and by using x naught you will be finding x1, and by using x1 you will find y1, and by using x1 you will find x2, and by using x2 you will find y2. That means you are moving step by step, and this kind of method we will call it as single step method. Okay, you are calculating the next value by using the previous value or the current value. Just that is, you are going to calculate x2 and y2. You are going to calculate x2 and y2 by using x1 and y1, and this method is known as single step method. And the Taylor series method is a single step method. And also you can see that in Taylor series method we will not use any values other than xn and yn for calculating xn plus 1 and yn plus 1. So let us see what is Taylor series. And all of you know that the Taylor series is given by Taylor series of any function f of x, any function f of x can be given as f of x naught plus, you can see it is given as x of x minus x naught by 1 factorial into f of x naught, okay, dash, am I correct, plus x minus x naught the whole square by 2 factorial into f double dash of x naught plus x minus x naught the whole square by 3 factorial into f triple dash of x naught. Okay, so this is double dash, sorry, not square here, this is cube f triple dash x naught. And what is this f dash? F dash of x naught is nothing but of any function, okay, any function, you can say any function, you can write it as I think I need to change the notation. So f dash of x naught is, okay, f dash of, I will use the notation f of x. So f of x is nothing but y is nothing but f of x, or I can say that it is nothing but y of x, y as a function of x. Okay, so f dash of x naught is nothing but d by dx of f of x. It is nothing but d by dx f of x, we can say it is nothing but y, okay, d by dx of y or dy by dx, and at which point, at x is equal to x naught. Then f dash double dash of x naught is nothing but d square of f of x by, this is at x is equal to x naught, d square f of x by dx square at x is equal to x naught. We can say that it is nothing but dy by dx at x is equal to d square y by dx square at x is equal to x naught. So that means you can say this is the first order derivative, this is the second order derivative, and this is the third order derivative. That's what. Okay, so we can write the Taylor series in another way also. Instead of f of x we will use y. So we are going to replace this f of x with y. So any function y can be written as y of x0. Y of x0 we will call it as y0. Okay, it is nothing but y0 plus x minus x0 divided by 1 factorial into y dash of 0, right, plus x minus what is y dash? Y dash is nothing but the first order derivative, x minus x0 the whole square by 2 factorial into y double dash of 0, and this is nothing but the second order derivative at x0, and plus x minus x naught the whole cube by 3 factorial into y naught triple dash. Okay, plus and so on, it will go on. Okay, it will go on. So this is what the Taylor series. So we have the Taylor series in this form. Okay, I will those who are having the confusion, I will explain it once more. So the Taylor series is given by any function y can be written as y naught plus x minus x naught divided by 1 factorial into y naught dash plus x minus x naught the whole square divided by 2 factorial into y naught double dash plus x minus x naught the whole cube divided by 3 factorial into y naught triple dash plus etc etc. Okay, and what is this y naught? Y naught is nothing but y of x. It is nothing but y of x naught. Okay, and what is this? This is nothing but y dash of x naught. And what is this? This is nothing but y double dash at the point x naught. Now suppose we have the point x naught. Suppose we have x naught and y naught, which is given as the initial values. So initial values, we have already discussed what is initial value problem. So these are all given as initial values. Now we want to find first x1 and then obtain y1, right? Now we have to move little bit. For example, you are going to find a function. Now it has been given, x0 is given, and what is the corresponding value of y, and y0 is given. Okay, now we want to proceed further to obtain x1. So we will choose a very nearby point. We will not choose any point here or here or here. Maybe we will not choose any point here because it is very far away from x0. So we will choose a very nearby point x1. And what is this x1? x1 is equal to x0 plus h, where h is the step size. H is known as the step size. It is a very small real number. Okay, it is the step size. Now at this x1 we will calculate what is the y1. We don't know what is y1. Okay, so it has been given x0 is given, and y0 is given, but we are going to find y1. So how we are going to proceed? We will first find x1, after that we will find y1. So we will use this equation. You can see instead of y I am going to replace y1. Okay, so if y is equal to y1, you can say if y is equal to y1, that means we have to replace x with, that is x is equal to x1. What is x1? x1 is equal to x0 plus h. So we are going to replace this y with y1. y1 is equal to y0 plus, and what is x? X is nothing but x1, right? x1 minus x0 divided by 1 factorial plus then we will find x minus x0 the whole square divided by 2 factorial. So instead of x, I am going to use x1. 2 factorial into, sorry, I have missed in the first part, I have missed y0 dash, and this is y0 double dash plus x minus x0 the whole cube, right? Instead of x, I am going to use x1 divided by 3 factorial into y0 triple dash plus, and so on. Okay, so this method, this is known as the Taylor series for x1. Okay, so we are going to find y1 by in terms of x1. Now you know that x1 is equal to x0 plus h, because you have a point x0. Now you move to the another point x1, which is nothing but x0 plus h. So x1 minus x0 is equal to how much? It is nothing but h, right? So in the above equation, what is this? H. So you can see that this gap is nothing but h, or we can call this as the step size. Step size, okay, step size. And this is a very small number, okay, very small number usually, okay, maybe 0.1 or 0.001, maybe 0.2, like this, very small number. Now we will take this equation, we will write the Taylor series. So we have y1 is equal to, sorry, y1 is equal to x1 minus x0 is nothing but, so y1 is equal to y0 plus x1 minus x0 is nothing but h by 1 factorial, right, into, this is y0 dash, right, y0 dash plus x minus x0 the whole square, x minus x0 the whole square, you see here. So it is nothing but h square, okay, h square by 2 factorial into y0 double dash plus h square h cube by 3 factorial into y0 triple dash, and so on. This is what. So similarly you can calculate y2. If you replace this 1 with 2, then you have to replace this 0 with 1, right? So this is nothing but y1 plus h by 1 factorial, y1 dash plus h square by 2 factorial into y1 double dash plus h cube by 3 factorial into y1 triple dash plus, you can write, if there are fourth order, you can write like this, by 4 factorial into y1 4 dash, right, and so on. Similarly you can write y3 as in terms of y2. It is y3 is equal to y2 plus h by 1 factorial into y2 dash plus h square by 2 factorial into y2 double dash plus h cube by 3 factorial into y2 triple dash, and so on, like this, okay. So in general you can say that yn plus 1 can be written as, this can be proceeded further, right? It is nothing but yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash plus h cube by 3 factorial into yn triple dash and so on, right? That means you are calculating yn by using yn plus 1. You are calculating yn plus 1 by using yn. So this method is an explicit method, okay? Because on the right side there is no yn plus 1. If there is yn plus 1 on the right side, you have to solve this equation and obtain yn plus 1. You can see here yn plus 1 is a function of yn plus 1 is a function of, here you can see yn plus 1 is some function of yn and h. And what is this h? H is nothing but xn plus 1 minus xn. This is the h, right? So you can write like this. That is, you can write yn plus 1 is a function of yn and h. What is h? H is a function of hn plus 1 and xn. So that's why this is known as explicit method. And there is no yn plus 1 on the right side of this equation. So this is what you are going to use in the Taylor series of method, okay? That means in the Taylor series method, you will calculate in the Taylor series method, you will calculate yn as yn plus 1 is yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash plus h cube by 3 factorial into yn triple dash plus and so on. And what are this? These are all the derivatives, okay? And you know this yn dash. What is yn dash? Yn dash is nothing but dy by dx at x equal to xn. If you will find dy by dx, and dy by dx is nothing but your differential equation. It is nothing but your differential equation. So we will solve a problem, then it will be very clear to you, okay? So we may use sometimes, we will not use all the, because this is an infinite series. You can see that this series will never end. It is going. So we will truncate this series sometimes to third order. So truncation, we will call it as truncation. Suppose if we truncate to second order, then yn plus 1 is equal to yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash. And we will not use the remaining terms. That is known as truncation. Suppose if we truncate to the third order, we will not use all other values. So if we don't use the other values, actually definitely we will be getting an error, but sometimes this error will be very negligible. So we cannot include all the terms because it is a series with infinite number of terms. So this is yn plus 1 is given as yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash plus h cube by 3 factorial into yn triple dash. So this is nothing but the third order case. So this is the second and this is the third order case, okay? You can, in the third order, you are using the third order derivative of y, okay? So this is the truncation. Now we will see a problem by using the Taylor series. So in this problem, actually we are going to use the second order Taylor series. So the question is use second order Taylor series method, okay, Taylor series method, to solve dy by dx is equal to minus x into y square. Okay, this is the differential equation. Okay, I will write it in the next line. To solve dy by dx is equal to minus x into y square, and in the interval 2 and 3. So we want to obtain the solution in the interval 2 and 3. What is the function values in the interval 2 and 3? This is what we want to compute. And given that the value of h is equal to 0.1 and y of 2 is equal to 1. Okay, that means this is the initial condition. Okay, now we are going to solve this differential equation. Given that it is given h is equal to 0.1, right, and y of 2 is equal to 1, that means this is nothing but the initial condition, right? It is the initial condition, and we have an interval which is starting at 2 and it is ending at 3. And what are the points? You know, the increment is 0.1. That means we have the point 2.1, then 2.2, because the increment is 0.1, right? The increment is 0.1, and 2.3, this is the value of x, right? Because x is starting at 2 and it is ending at 3, and it is given in the question. Okay, now you see here, this is 2.3, this is 2.4, 2.5, 2.6, like this. Okay, then 2.7, 2.8, 2.9, then it is 3. So we want to obtain all this value. This is the value of x, and it is given x naught. Okay, it is given x naught, and what is this? This is x1, and this is x2, and this is given, and this is x3, and this is x4, and this is x5, and this is x6, and this is x7, and x8, x9, and x10. So it has been given for this value, that is the initial value for the initial condition, of x naught. That means this value is nothing but x naught. What is the value of y naught? This is given. You can see that these are given. Okay, and what is x naught? X naught is nothing but 2. X naught is 2, and y naught is given. You can see here y naught is given. Y of 2 is equal to 1, right? So y naught is 1. So x naught is equal to 2 and y naught equal to 1. This is given. This is given. Now we want to find for x1 what is y1, for x2 what is y2, for x3 what is y3, and so on up to this. For x10 what is y10. Okay, we want to find all the values. Then that is nothing but the solution of the differential equation. I hope that this is clear, right? So I will rewrite the differential equation once again. You can see here the differential equation was dy by dx, which is equal to minus x into y square, and it is given h is equal to 0.1, and x naught has been given, which is 2, and y naught is given, it is 1. Okay, and we want to find, and our interval is between 2 and 3. Okay, so first of all we will find the equation for the Taylor series. Okay, and we know that the Taylor series is having a form yn plus 1 is equal to yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash, right? And you can see here we want to use only the second order Taylor series. So the second order Taylor series will be having the form like this. This is only the second order Taylor series. So this is just the second order Taylor series. Okay, second order Taylor series. And you know this is dy by dx, right? Dy by dx is given minus x into y square. That is nothing but, this is nothing but y dash. So it is given already because it is evident from the differential equation. It is directly, we can directly, it is directly related to the differential equation, right? So we got this y dash is equal to minus x into y square. Now we want to find y double dash. That means we want to find d by dx of y dash, right? This is nothing but y double dash. This is nothing but we d by dx of what is y dash? It is minus x into y square. But you should note that this is x and this y. This y is a function of x, right? So y square is also a function of x. So we have to apply the product rule in the differentiation. Okay. So first of all, I will differentiate this function. So this is nothing but minus, it is nothing but, I will differentiate with respect to x. I will first start with differentiate. If you differentiate this function with respect to x, then only thing remaining is minus y square, because d by dx of x is 1, right? So those who are having confusion, I will write the steps. So this is nothing but your minus is already there, and d by dx of x is 1, then into y square, okay, then plus. Next, so you have differentiated with respect to x. After that you will differentiate with respect to y. So x is a constant, so it is minus x, it's already there. Then the d by dx of this y square is 2y into dy by dx. Am I correct? Yes. The d by dx of, that is, note that d by dx of y square is nothing but 2y into dy by dx. This is by using the chain rule, okay, chain rule of differentiation. Now y double dash, okay, y double dash is equal to, you can see here this one, so it will become minus y square, right, plus minus 2 into x into y, and dy by dx, you already know dy by dx is nothing but y dash, right? Dy by dx is nothing but y dash, right? So this is equal to minus y square, this minus 2 into x into y, and y dash, it is very clear from the equation because you know this y dash. What is y dash? It is nothing but minus x into y square. So this is nothing but minus y square plus minus y square plus how much? Minus y square plus 2 into x square into y into y cube, right? You can see this is x and this is x, so it is x square, and this is y, and y square become y cube, right? So this is what, so you got it. Now you got what is y dash. Y dash is nothing but minus x into y square, and you know y double dash is nothing but minus y square plus 2x square minus y square plus 2x square into y cube, or this is, you can write it as minus of y square into, you can write it in another way also, this, okay, this is nothing but, you can write it as, you can take the y square outside, so it is nothing but minus 1 plus, sorry, this is cube, so minus 1 plus 2 into x square y, you can write it like this. Okay, so you got both y dash and y double dash. Now you just need to substitute in the equation. So yn plus 1 is equal to, we have our equation, I will write it once again, yn plus h by 1 factorial into yn dash plus h square by 2 factorial into yn double dash. This is nothing but the second order case. Okay, second order Taylor series. Okay, now we will substitute, instead of y we will use yn plus 1 here, then this is nothing but yn plus h by 1 factorial. You know what is y dash, right? So it is nothing but minus, it is nothing but minus x into, it is nothing but minus x into y square, right? When we are going to calculate yn, we want yn, so we will put x is equal to xn and y equal to yn, isn't it? Plus h square by 2 factorial into, we know we have to substitute here yn double dash, and y double dash we know, so we will just substitute here. This is y square minus 1 plus 2 minus 1 plus 2 x square y, right? Now instead of y we will put yn, instead of x we will put xn, instead of y we will put yn. So we got the equation, right? So this is nothing but, we can say, we will simplify this equation once again. Yn plus 1 is equal to yn plus h by 1 factorial is h, and you can see here we have something common. You can see here yn square is common, yn square is common, so we will put yn square, h into yn square, then so h into yn square, then we will put a big bracket here. Okay, you can see we will put a curly bracket, yn square, then what is remaining here, minus x, your minus x is remaining, and yn square is already taken out, so this plus h square by 2 factorial means what, 1 into 2, that means h square by 2, and you have already taken one h outside, so this is nothing but h by 2, see, isn't it? Or you can use the previous equation directly itself. I am just going to simplify, that's what. So instead of this is xn, now this is h square by 2, and yn square is already taken outside and one h has been taken outside, so you see if you multiply you will get h into yn square into xn, that's what you are getting here, and then h into h means h square by 2 into minus 1 plus 2 into xn square into yn. So this is the equation that you are going to get. Okay, both are same. The equation, for example, this is equation A and equation B, both are same. Okay, equation A is equal to equation B, because equation B is the simplified form of A. If you multiply everything you will get the same equation. Okay, now I will rewrite in the next page for the sake of convenience. You can see yn plus 1 is equal to yn plus h into yn square into minus xn plus h by 2 into minus 1 plus 2 into xn square into yn and you are getting this. Okay, this is the equation for calculating yn. You can see that by using this equation we can calculate yn plus 1 by using yn, that is the previous value of y by n is here. You can see here xn is there. We need to know what is h, and we need to know xn, yn, everything is there. So we are going to find the solution. So the table, we are going to draw the table now. This is xn, and we are going to calculate yn. Yn is nothing but, it is nothing but y of the xn. Okay, now it is given the initial value x naught is equal to 2. So in the initial value it is given that what is y naught equal to 1, right? So it is given here. So we will use this term. You know that y naught equal to 1. Now by using h, we have h is equal to 0.1. So we will calculate x1. x1 is equal to x naught plus h. It is nothing but 2 plus 0.1, right? 2 plus 0.1 is nothing but 2.1, right? Now we will calculate what is y1. y1, we will use this equation b. We will use the equation b. What is y1? You put n equal to 0 here, then y1 is nothing but y naught plus h into y naught square minus x naught plus h by 2 into minus 1 plus 2 into x naught square into y naught, right? And you know whatever values are required for this equation, to solve this equation, because y naught is given, it is 1, and again here it's y naught is given, and you know what is x naught, and you know what is x naught here, right? This is x naught here, and what is y naught here. So everything you know. So you just substitute and you will get the value of y1 as 0.8299. okay, 8299. I hope that okay. So y of xn, you will be getting yn plus 1, right? Now we will calculate by using, I think it is correct, please check the calculations. Okay, now we will calculate x2. What is x2? x2 is x1 plus h is nothing but 2.2. For 2.2 we will calculate y2. So you will get the value of y2. Okay, so sorry, this I have made a mistake here. This is not 0.0. This is the value that you are going to get is 0.835. okay. Next, after that, y2 can be obtained by using y1. y1 plus h into y1 square minus x1 plus h by 2 into minus 1 plus 2 into x1 square into y1, right? This is how. So if you calculate, you know everything, because you got y1 by using the previous equation, right? So you got y1 here. This is the same y1 square. Now x1, you know what is x1, and x1 is clear here, and also y1 is also used here, right? So by using all these values, you can calculate the new value of y2. That means y2, you can calculate it as 0.7108. okay. So similarly, you will get x3 as 2.3, and you will get y3 as 0.6145. Then x4 is equal to 2.4. You will get it as, this is y3 and this is y4. You will get y4 as 0.5380. Then for x5 is nothing but 2.5, because h is 0.1, so it is very easy to calculate. And y5 you will get 0.4761. Okay. Similarly, you can calculate x6 and y6. x6 is 2.6 and y6 you will get 0.4250. Okay, and so on. So you can use the same equation that we have already derived, right? So you can use the same equation for a particular problem. Once this equation has been derived, you can calculate it for any, you can use it for finding any value. Okay, so x6, x7, what is x7? x7 is x7 is 2.7. In 2.7 you will get y7 as 0.3823. okay. Now x8 is 2.8. you will get y8 as 0.3462. then x9 is 2.9, 2.9. so y9 you will get it as 0.3153. okay. Then x10 is 3, because we want to find it for the interval 2 to 3, right? So we will stop here at 3. So y10 is equal to 0.2886. okay. So this is what the solution of this differential equation. So for different values also we got the function. Okay, so this is what the solution of the differential equation. So I will clarify you once again. I hope that this is clear. So I will clarify you once again. So first of all, we have to solve this problem by using the second order Taylor series approximation. You can see we are going to use the second order Taylor series approximation, and it is given h is equal to 0.1. It is given 0.1 and y of 2 is equal to 1. So what is this 2? It is nothing but x naught, and this is nothing but y naught. Okay, so both are given, and it has been asked to obtain the solution for the interval 2 to 3, and the increment is given as 0.1. so you can see it is, we are starting from 2, and we are ending at 3. So the different points between 2 and 3 with an interval or with a step size of 0.1 is nothing but, it is starting with 2, next point will be 2.1, because h is equal to 0.1. so 2 plus 0.1 is 2.1, and we will get x2, we will get x3, and so on. Okay, now we will write the general, this is our differential equation, and this is the differential equation is nothing but the y dash. Okay, because we are talking about the first order differential equation. Okay, so it is y dash, not y1, y dash. So dy by dx is nothing but y dash. And to calculate the Taylor series, you know, this is the Taylor series, right, with the second order Taylor series, because in the question it is given second order, so we have to use the second order Taylor series. The Taylor series include yn dash and yn double dash, but yn dash can be directly calculated from the differential equation, because differential equation itself is the first order derivative. Now we have to find the second order derivative. So while finding the second order derivative, you should be very careful, because second order derivative involve the chain rule. So at first we will take this equation. So we will first differentiate with respect to x. If you differentiate with respect to x, then differential of x with y with respect to x is nothing but -1. Okay, you can see this is -1. Then the remaining thing is y square, so we will put y square, plus we will keep x as such, you can see here. After that we will differentiate this y square, if you differentiate y square, it becomes 2 times y into dy by dx. So we can write this differential y double dash, this is the y double dash, we can write it here. You can see this is become, it has become minus y square plus minus 2 into x into y into dy by dx is nothing but y dash. So we will simplify this equation and we will get this value, and after that we will put this value of y dash and we will put the value of y double dash in the Taylor series. Okay, this is our Taylor series. Now you will get some equation like this, and you can simplify this, simplify into this form. Even though if you don't do the simplification, there is no issue. If you simplify, it will be more easy for you to calculate by using the Hasiba calculator. Okay, now after simplification we got the equation. This is our final equation. Okay, final equation. After getting the final equation, you will start with x naught, because for x naught equal to 2, you know what is y naught. Okay, and after that you will find x1. What is x1? x1 is nothing but x naught plus h, that is the next point in x. Next point in x is 2.1. so you got x1, you got, you know what is y naught, and you know what is x naught. So by using these values, actually you will be finding the next value of the function. Okay, so you will use the equation and you will substitute and you will get the value of y1. Once you get y1, then for x2 you will find y2, then for x3 you will find y3, for x4 you will find y4. Like this you will proceed and you will continue until you reach 3, because we want to calculate in the interval between 2 to 3, and the value of the function, this is the initial condition, has been given. Okay, initial value is given, initial condition is given. Okay, is given. Okay, then we will calculate the whole thing, right? So in the next lecture we will explain one more problem. After that we will move on to the next method. I hope that this is clear. Okay, Assalamu alaikum warahmatullahi.